I put together this video to help students out with the last two problems in the stoichiometry introduction activity. Both of these problems involve limiting an excess and require two calculations in each one. Let's take a look at the first one. I'll leave you guys to the second one. If you have questions, you can contact me. In the first question, we have 120 milliliters solution, but in that solution, we have 0.196 molar sodium bicarbonate, and we're also going to have 0.043 molar citric acid. Now, because both of these compounds are in the same solution, they both have the same volume. So we have 120 milliliters of a 0.043 molar citric acid solution, and at the same time we have 120 milliliters of a 0.196 molar sodium bicarbonate solution. Let's take a look at how we solve this problem. The first thing we need is a written out balanced chemical equation. So sodium bicarbonate is going to react with citric acid. That is going to produce sodium citrate, water, and carbon dioxide. When we balance it, we get coefficients of 3 on the sodium bicarbonate, water, and carbon dioxide. Next, we're going to start the first of two stoichiometry problems. We're going to start off with our 120 milliliter solution of sodium bicarbonate. The molarity of the sodium bicarbonate is 0.196 molar, which means that in 1,000 milliliters we have 0.196 moles of sodium bicarbonate. This we are going to use to convert that 120 milliliters into moles. Next, as with all stoichiometry problems, we do our mole to mole ratio. In our balanced chemical equation, we have 3 moles of sodium bicarbonate and 1 mole of sodium citrate. The last step is to convert that moles into grams, since the question is asking how many grams of sodium citrate will be. We get the 258.08 grams off of the periodic table by adding up the masses, and that is equivalent to 1 mole. We calculate that out and we find that we get 2.02 grams of sodium citrate. We now start the second stoichiometry problem, and we use our 120 milliliters again, this time with citric acid. We use the molarity of the citric acid to convert to moles. We do our mole to mole conversion, and we finally find our mass by using the molar mass that we determined above as well. This mass we determined to be 1.33 grams of sodium citrate. Now, since we have two different answers, only one of them can be correct. The smaller value of 1.33, this is what we are going to call our theoretical yield. That's the least amount of sodium citrate that can be produced between these two compounds. That means that the citric acid was the limiting reactant and the sodium bicarbonate was the excess reactant. The same basic principle is going to be used on the next problem. Other problems similar to this may give you two different volumes of solutions that are going to be mixed together. In that case, you would simply use whatever volume of that compound that you are using. In this case, we simply had 120 milliliters of solution with both of these present. Therefore, the same volume for each compound was being used.